Good morning all. The poster and rangoli competition is over. So I'd like to start the third guest lecture in Geo-Fest 2022. I'd like to invite Akash to introduce Dr. Markand.
Good afternoon. I am Akash Padodia from MSc Part 1 on behalf of Department of Geography, XP College. Take this opportunity to introduce you all to Dr. Markand Oja sir. Dr. Oja has pursued a PhD degree in statistics from IIT Kanpur. He has worked extensively in the field of remote sensing and GIS and has executed national level projects. He has worked as senior scientist in Space Application Center, ISRO. He was the head of the content generation and data dissemination division of VEDAS, that is, visualization of Earth observation data and archival system. His notable contribution is in the end-to-end technical development, proof of concept demonstration, and its national level execution realization of fossil product. His thematic work encompasses digital image processing techniques for forestry, agriculture, and atmospheric sciences using satellite sensor data. His recent interest includes web analytics. He has published more than 50 scientific papers in international and national level peer-reviewed journals. He was an associate editor of the Journal of Geomatics for 6 years. Presently, he is a member of Board of Studies at the School of Informatics, Digital University of Kerala. His topic for the today's lecture is Earth observation data for assessing sustainable development. I would like to invite Dr. Oja sir to deliver his thoughts on the topic. Over to you, sir.
Hello. Good morning, all. I hope my slide is visible. Can I start? Hello. Can I start?
Yes, sir.
Sir, are you there?
Yeah. Can I start?
Yes, we can hear you, sir. Yes, we can start. Thank you.
Okay. Can you see my screen?
Yes, sir.
Okay. So I'll be trying to tell you how Earth observation data can be used and is being used for assessing sustainable development. To begin with, I'll try to cover in this manner. I'll give few quick interpretations which are valid only for this lecture. Okay. Then some applications where Earth observations contribute significantly in sustainable development assessment thereof. And time permitting, I'll talk about some web GIS platforms and future trends and try to conclude what I want to do by message. Now, in applications, I want to touch upon disaster management, how Earth observation can support, how it can and it is supporting vegetation monitoring, new and renewable energy, including over urban area, quick slides on inland water monitoring, air pollution, and cryosphere monitoring. Now, as you may be aware, there are 17 SDGs, but I'm not going to go SDG wise. Instead, I'll take up case studies where Earth observation, impact of Earth observation can be seen, smelt, and felt by the participants. So, first, some of the definitions. Okay, Earth observation means satellite data as well as data from aerial platforms and drones. However, many a times ground sensor network data communicated via satellite is also included. So basically, we want to study physical, chemical, and biological systems of the Mother Earth. So most contribution comes from satellite. Now, as you may be aware, and you may be listening for last 2-3 days, important parameters or important impact of satellite data is it is cheap, it has wide coverage, and it has various temporal as well as spatial resolutions. Now, how judiciously we combine all this to support natural resource inventory or to find out causes and understand the processes which affect. Okay, so first I'll start with term called inventory. When I say inventory, that means what is the current status. For example, I said inventory of crop means what is the status of crop as on today. Basically, it would mean how much crop is there and where it is. That means it will tell in terms of how much is now this Rabi season. So wheat, how much is there in Punjab, how much is in Gujarat, how much is in Maharashtra, how much is in UP. So basically, inventory means single date or single season analysis and information, thematic information derived from this. That is inventory. Whereas more impact or meaningful thing is change analysis. That means now this year's crop or this year's vegetation, how it is different from last year or from a benchmark year. That will tell changes. So basically it is minimum 2-date analysis and difference and identify how much things have changed, whether change is 5%, 10%, minus, plus, and where they have changed, whether there are any pockets where things have changed. So that is what I call change analysis. But the emphasis is on assessment. Assessment means necessarily multi-year or multi-season inventory organized so that, you see, purpose of inventory is how much is available. Change means how much has changed and where it has changed. Whereas assessment means I want to know what are the long-term trends and I want to understand the processes and what are the drivers that have contributed to this change. Okay, then in sustainable development goals, these terms come very often. Tier 1 type of applications, Tier 2 type of contribution, Tier 3. So what do they mean? Tier T means things that are fairly mature, conceptually clear, as well as things are now widely accepted as operational. Operational means come what may, you should be able to give. That means a very robust, consistent and replicable procedures, if adopted, will give same results or similar results. So, for example, we'll see vegetation monitoring is at very high level of majority. That means if participating nations or states adopt similar data and similar approach, they will give consistent data as well as data products. So now FAO and United Nations office, they recommend that wherever maturity of EO extracting information using EO data is there should be inventory which should be reviewed once, maybe every 2 years or every 4 years, and then see what are the changes and why there are changes, and see whether anything can be done, human intervention or managerial intervention, whether they can stop degradation. Whereas tier 2 means they are quasi-operational. They have worked well somewhere, but they need to be scaled out so that more people, more countries can try and give. The basic aim is to make a unified, standardized database so that long-term trend changes can be identified as well as drivers of them can be decoded. Okay. Whereas tier 3 is slightly R&D stage, and they need to be demonstrated over space and time, because many a times under ideal conditions the methodologies work and produce results, but each year the situation may not be ideal and there may be a lot of variations in accuracy, and such databases have much less meaning and relevance. Okay, now I'll start with first case of disaster management. One of the severest disasters is cyclones. Okay, now it is, if you take away satellite and earth observation data, it is very, very difficult to forecast and take appropriate action to mitigate, say, cyclones. For example, nowadays, if you see Indian East Coast, in fact West Coast also, but East Coast is more dominant, every year gets 3 to 5 cyclones. Now, these cyclones, if they can be, how or where they have generated, they can be easily assessed or interpreted using earth observation data of temperature, humidity, salinity, and in my frank opinion, it is very difficult to gauge whether a particular environmental situation will generate cyclone or not, and if it generates, what is the path it takes, how much time it will take before it hits a land affected area. That means where it will hit. For example, in Indian coast, whether it will hit Tamil Nadu, Andhra Pradesh, Orissa, or it will take a curl and go to Bangladesh. And one of the major impacts is human life is most precious and must be given highest priority to be saved. If you remember, in 1990s, a cyclone used to typically, in cyclone, we used to lose lives of hundreds of people. It was in 3 figures and sometimes 4 figures also. But recently, the damage to human and animal life is much less. It's not that impact is less, same intensity cyclones, but the impact is much, much reduced, because a week in advance, we are able to start watching and issuing alert that conditions favorable to generation of cyclones and hurricanes have happened maybe 700, 800 kilometers inside the sea. It is likely to take place, and 2-3 days before it actually strikes, we are able to pinpoint within plus minus 50 kilometers that it is going to hit which of the coast, and based on this information, the administration takes precautions and care and manages and asks people not to venture into sea, asks low-lying people residing in low-lying area to shift to elsewhere. And one of the recent reports says that the lives lost are probably those who are reluctant to leave their place, either because of resource constraint or because of old age or there are personal reasons that they don't want to leave their place in spite of warning information being available that rain and wind, high wind velocity is going to take place. So, okay, this is one of the major natural disaster. Another is floods. Now, as soon as, floods is a very routine phenomena and it affects human lives as well as comfort and loss of natural resources. So, in such cases, there is one international charter which is called Space and Major Disaster. So, EO, there are 17 space-faring countries who have agreed to share their data and tilt their resources, space resources, as and when and natural phenomena occurs. For example, if there is an earthquake, then space agencies which operate the satellites, they will try to capture and get the information or data of the affected region. So there is a need to have pre-disaster data as well as post-disaster data. The turnaround time of getting data and processing should be minimal so that managers who are assigned to mitigate sufferings of the people, they get correct information in minimum of the time. Now, the data is one thing, but processing and getting the information, derived information, is another thing. So, this consortium of spacefaring nations have made this platform and they have developed an automated processing chain which accepts the data, basically the affected country as a project manager who triggers that, okay, that there is a disaster in this region, marks an area of interest, AOI, and all spacefaring nations, they try to push their data here. And then analysis on the web. You see here, importance is more on timeliness rather than on science part, because whatever is matured, they are used and image differences and such operations on web, they are enabled or functionalities are provided and a PDF report is generated which can be sent to state or national disaster authority so that appropriate management actions can be taken. I'll give one example. For example, these floods of Kerala. Now, as soon as flood takes place, Kerala or India will announce on the relevant forum that this is the region where flood has taken place. So immediately Sentinel, Landsat, JAXA, optical, microwave, Korean sat, everybody will see whether they can acquire the data over this region and push it here. Now, at this place, what needs to be done is quickly have high resolution elevation data, land use, land cover data, so that the managers know which are the locally elevated areas where people may be asked to shift. So here the functionalities required are, we want to clip image, because you see, if you take full image, it's a huge burden on servers. So they will, as soon as data comes, they will clip to area of interest. Then most simplest but still most impactful parameter is difference. What is the difference between, say, pre-flood and post-flood? So that is new added flood area. Similarly, many a times some indices like A minus B upon A plus B, NDVI, normalized difference vegetation index, or even water index, they can be made using this. So they should be able to quickly make a difference images as well as composite. Other things, I think users may be knowing how to generate mask, apply the mask, and as most of the students would be knowing, the data needs some pre-processing like image filtering, particularly microwave data. So after pre-processing, the differences and all this can be generated and mapped. Now I'll take to another very important and significant theme called vegetation assessment. I've deliberately taken the season of last Kharif season and I've taken state as Maharashtra. Now this dashboard is available on vedas.sac.gov.in, but I'll tell what it does. For example, here you can see VCI is Vegetation Condition Assessment in Maharashtra as on 21st September. As soon as I go to vegetation condition dashboard, which I'll show you time permitting at the end, then it has various parameters. I have chosen NDVI, but there's rainfall also, then NDWI also. Now, if I don't take anything here, it will give me state-wise performance of vegetation condition. Now, what is vegetation condition? That means, suppose I have database of 20 years, what was the minimum NDVI of these 20 years at a pixel? Similarly, what was the maximum? So, I know what is the worst condition and what is the best condition encountered on ground so far. That's why database has to be large. And in 20 years, we expect there would have been a bumper year as well as a very bad year. Now, what is current year's NDVI with respect to minimum? Minimum, I will say 0. Maximum, best condition is 100. Now, what is the condition this year? Is it 60, 80 or 40? And then they have been categorized. So, various columns you see, VCI. VCI is nothing but current year's NDVI minus NDVI minimum divided by maximum NDVI minus minimum NDVI. Okay. So now if I go to district, then I can go to, now beauty of this is as soon as I select, I can get pie diagram as well as spatial diagram, which shows, for example, in September 21, as on 50% of the districts in Maharashtra were having very poor performance, whereas only 4 districts, that means 11%, had a very good performance of vegetation as indicated by NDVI. Okay. Now, if I select a district, after state I choose Pune, same date, then what I get is that 8 out of maybe there are 8 to 20 or odd taluks, they had very poor condition, and 1 or 2, 3 taluks had a reasonably good vegetation condition. So similarly, this dashboard will help you to know what is the, tabular status as well as spatial status. It's not only that, it will also tell, for example, as on 21st September, how has been the NDVI trend for the last 6 or 8 time points. That means what is the performance of current season, as well as it will say what is the condition of 21st September as in last 8-10 years. Now both of this will tell you whether there is a change, there is a sudden change in this year, or there is a change, at this particular point, or in the entire growing season of the crop. So similarly, for entire India, you can have a long-term trend also at each pixel. Now, all what I showed is available on Vedas platform. Now, one term is called granularity. Now, that means whether you want at pixel level or taluk level or district level, you choose and you will get such maps. For example, I have taken 2 points. 1 point which I don't know what is Hismat, but Hismat must be some taluk or district in Maharashtra. There is a negative trend in last 20 years, whereas there is a positive trend in Nanded. Now, For this, knowing the trend, I have taken May data. Why May? Because you see, generally May is pre-monsoon season, probably driest of all, and if there is a moisture deficit, then it will be reflected. So pre-monsoon is the best season as far as knowing long-term condition is considered. It's not only that you know what is the present status as well as what was the status in past 6-4 time points as well as in past few years, but also importance is in knowing what is likely to be NDVI in the next fortnight or in a month or so. For such things, data have been trained using machine learning techniques. LSTM has been adopted, and routinely 16-day and basically T+1 and T+2 forecast of NDVI time series all over India is also provided, so that managers sitting on the server room and providing correct information to decision makers, they can guess what is going to be growth of vegetation, whether it is going to be normal, below normal, or above normal. If it below normal, what are the measures that need to be taken? They can consult concerned agrometeorologist or agronomist and find out whether is there anything that humans can do to salvage if the condition is not appropriate. Okay, so this was about vegetation monitoring. Another important thing, natural resources, energy. You see, first is disaster, human life as well as, in fact, all living beings are important. So then vegetation, because we need food to survive. And third important to me is energy. Now, what I'm showing is animation of monthly insolation. Insolation means incoming solar radiation. Now, these atlases have been made using geostationary platform, which acquire data every half an hour. I compile over day, compile over month, compile over year, and I have such data sets of 12 to 15 years, and I make what is average incoming solar radiation in the month of January, February. As you can see, winter months is less, as it will be highest in May, then again due to cloudiness, incoming solar radiation would be less. Now, how this is helpful? You see, there is lot of talk of trapping new and renewable energy, so that dependence on fossil fuel is reduced, pollution is minimized, and for that there is a need that we harness the new and renewable resource. For that, solar calculator has been prepared, and what it tells is either it's a mobile device, so wherever you go and click, it will note the latitude, longitude, and give month-wise as well as annual minimum, maximum incoming solar radiation as well as temperature. Temperature is processed using IMD data. Now, why temperature is needed? Because performance of solar panels is also affected by the ambient temperature. So, and then local terrain, whether it will obstruct or not. If it is in valley, the day length would be less. So all things that are relevant for calculating and what will be the rooftop solar radiation can be generated. It will give as an output. So I encourage all the students and participants to download this app from vedas.sac.gov.in and use there. And if any more collateral information is required and they feel it will be useful, they can write to vedas.sac.gov.in and they will be able to provide. Now, if you remember, a couple of months back, Prime Minister had promised to provide global solar calculator. Now, it was on this basis that Prime Minister had confidence that Earth observation data can be used to generate solar calculator. Indeed, solar calculator for Africa has already been made, and beta version for knowing what is the solar energy available at various places in the world is also available with us. But for India and for Africa, it has been published and it is available. Okay, so I'll give you now. This is about national, but if you come to a small, you see there is a concept called solar cities, and so what is the amount of energy that can be tapped in a particular city? That is the question. Because only if you know how much is the potential, then you can know what is the performance, how much has been tapped, and where are the gap areas. For example, this is an example of Ahmedabad city. So in city, it is built up area. So basically land use land cover classification is done, and only on built up areas, solar panels can be built. Now, in built up, then you have to see what is the adjoining area. That means if there are tall towers besides my low-rise building, then there will be a lot of shadows. So considering all such things, what is the potential of solar tapping solar energy in a city can be mapped. In fact, it has been mapped for all 60 solar cities of India. Okay, now this is what I was telling about adjacency and high-rise building. What is the direction and what will be the direction of sun, high-rise building versus your building, and how much area would be covered by shadow for a particular location. So from a India level, we came to a city level. From city level, I come to my terrace level. However, very high resolution stereo pair data from satellite or aerial or drones is required to be able to calculate all this. But it is possible, it is doable, it has been done. So, okay. Then another interesting case is now 2-3 years back, there were a lot of what we call flash floods, or there was urban flooding. So a lot of PIL went to Supreme Court that it is because of the mismanagement that people are losing their peace of mind, which is one of the goals of sustainable development, and something must be done. We asked 2 or 3 wetlands are there. What were there 10 years ago? What is it now? Now, to answer such things, I do not think that there is a reliable mechanism other than Earth observation data. Now, this task was given to Space Application Center to give quickly first number of water bodies or wetlands. So basically what it meant was you take high resolution data of entire India in a particular year. In this case, it was 2006-7. How many water bodies? Water is very easy to identify even in optical data. And Supreme Court doesn't know what is optical data, what is resolution, what is microwave data. They simply said, first quickly give us number of water bodies in 2006-7 and what is it now. So for that, 2017-18 data was acquired, and first is number, and then little later give detailed analysis of area. You see, water body might have shrunk, so number may remain the same, but area might have decreased. So basically it is to identify what is causing urban flooding. So now these maps have been prepared. For that, as you can see, 650 scenes of resources at 2 and 2A were analyzed. Now, you see, another important factor for interpretation is spatial resolution as well as minimum mapping unit. This was done using listed data. Now, the exercise is on using this food in much finer spatial resolution. This will tell that what is the decadal change in water bodies. Another thing, now this is what I call tier 1 procedure, land degradation. FAO has clearly defined a procedure which has to be followed by each participating nation, and they have to report what is the status of land. So in that there are 3 categories: land use, land cover, processes, which process is making degradation or improvement, and severity, whether it is medium, low or high. And that means a prescribed procedure is available, each country is supposed to follow, and there is a goal to reclaim wasted land to the extent of 30% of waste land available. So for India, if I speak, we have roughly 23% of land degradation which has to be reclaimed, and this has been brought down to 18 or 19% by 2030. This is the goal that we have set for ourselves, and so making such changes, we can know where the improvement has taken place and where degradation has taken place. Now, another very impressive use of Earth observation data actually used was near Borivali. There is a Sanjay Gandhi National Park. Now, big builders and building lobbies, they had captured the land, and then using good legal support, they wanted to claim that tribal people should not be disturbed, and so there's some predefined sets that those residing for 15 years or more, they cannot be shifted. So they said that wherever we have made built up, it is not a recent built up, but an old build up. So remote sensing data of past was analyzed, and it was conclusively proved that 12 years before the case was taken up, the area had a vegetation. That's why the built up is recent, and there is no legal bound to throw away people who have moved there. So that means Earth observation data has received recognition of High Court also. So you see, I told you about wetlands. Supreme Court also has used it. So EO, Earth observation, is an inseparable tool even for, and has legal implications and validated values. Now, very important theme is cryosphere. Cryosphere means snow, ice, high albedo regions. Now, they are very important in hydrological cycle as well as most important in atmospheric, because if our snow cover is reduced, then what does snow do? You know, it's a high albedo. That means most of the energy is reflected, and that's why our place is habitable. Otherwise, there will be significant rise in temperature, and it will be very difficult for us as well as other biotic things to survive for a long time. That's why. Now, another thing is, you see, most of potable water is stored in glaciers. So it is very important to know what is happening to cryosphere. They are very famously called 3 poles of Mother Earth. North Pole, South Pole, and Himalayan is called the 3rd pole, because these are the highest reserves of snow and glaciers, and they modulate the thermal regime as well as they facilitate water regime. So now, I do not know whether, other than Earth observation, whether there is any meaningful mechanism which can do global inventory as well as assessment as far as snow and glaciers are concerned. Another important thing is studying Arctic and Antarctic, which provide laboratory for pristine environment, so that whatever changes are happening there, they are purely natural, much because there is very little or no population, so human intervention is not there, anthropogenic pressure is not there. So what is happening is purely natural. So if we study over India and Antarctic, the difference between that can be, as a zeroth level, can be considered as contribution coming from anthropogenic sources. Then there are other things like air pollution monitoring. That means people staying in North India, particularly Delhi, they will be knowing that in November, December, there will be a lot of pollution, and they will attribute it to stubble burning in Punjab and Haryana. Now, farmers in Punjab and Haryana, they will be saying that since our harvesting was delayed because of policy intervention, we could not sow early, and time between harvest of Kharif and sowing of Rabi is less. So we are forced to do this. This is not an environmental problem, this is social problem, this is economic problem, problem of availability of labor. So it's a very intricate thing. Now, so, but to monitor it, what can be done? We have aerosol optical derived from Earth observation data. Then there are various station data available. This is the case of Delhi, where station data is available. They are mapped and managed every half an hour. PM 2.5, PM 10. The data are pushed to servers. Servers elsewhere they catch it and give in publish in visualizable form. And so this type of data is there. So concerned scientists can judge whether it is aerosol, what is the direction of wind, and probably generate advisory, so that knowing what is the load of dust, what is aerosol, what is burning. Now, fire burning is a regular product available from INSET as well as NPOS. So such data is available. The challenge is to use this data, make a platform which can catch all this data and put it in a simple form where people can understand and policymakers can make a reasonably reliable forecast and do something temporarily as well as in long term to make some impact. Okay, so I'll end by saying, there are 17 SDGs, of which Earth observation has capability contributing 13. Not all is tier 1, some are tier 2 and few are tier 3. Among this, SDG 6, clean water and sanitation, sustainable cities and communities, coastal water and life on land have significant potential. But the punchline is EO data is accurate, consistent, reliable and affordable. Because many a times in earlier scenario, it used to happen that they used to doubt quality of data collected by poor countries or developing countries, saying that you don't invest so much. Now, what the data developed countries use, same data, because of global coverage, are being used by all countries. Same standard operating procedures, that means definition, what is applicable to Europe is applicable to Africa, is applicable to Asia. So consistent application, consistent definition, same data can be used, and maps can be prepared, and maps over a period of time will tell whether whether degradation is taking place, forest is a culprit, or whatever is there. Okay. So I'll end with saying that Earth observation has a role to play. Probably it is the cheapest per square kilometer, and it can be used to assess whether sustainable goals are being achieved. They are stagnant, they are accelerating, it is cost effective, and it is available many scales, space as well as time. For example, if you want to monitor
अरे
forest,
तिथून पडेल म्हणून
most
ते ठेवलं.
resolution will suffice.
घेऊन जाऊ
But
का
if
हे?
you want to go
ती मला म्हणते घेऊन जा.
to urban area, you need to go to finer spatial resolution. Finer spatial resolution will mean a lot of data, but you will compromise on temporal resolution. But you can have train of satellite data or drones to. So the takeaway is considerable amount of data provided by geosources. You see, again, I'll like to emphasize that data are consistent, but methodologies also need to be consistent to produce same quality of data. Due to shortage of time, I have not touched atmospheric and oceanic parameters, but there are various databases available globally which indeed studies what are the trends, what are the future scenarios in ocean, in temperature, in rainfall. For example, very famous is in India, though Northeast is a hotspot of rain water, but amount of rainfall is decreasing in Northeast. Now, whether it is due to effect of transportation in Indo-Gangetic belt and all this, they need to be studied. They will come under R&D objectives. They will be year 3, but they also need to be studied. For that, students have to take up research problems. Once they mature, they have to show proof of concept, and ultimately, when it matures and many people agree about reliability and accuracy of such products, it can be made into tier 1 product, and such assessment reports regularly to national and international bodies will tell us whether we have our direction to achieve sustainable development targets can be achieved or not. And things like cryosphere, I do not think there is alternate to Earth observation. So Earth observation, there are applications where there is no alternate. There are applications which are mature, cheap. I'll put agriculture under that, and there are various other things where a lot of research needs to be done, but there is a lot of potential for EO to contribute in assessing health of our planet health. Thank you. If there are questions, welcome. Yeah, I'm through. Any questions? Hello?
Now this question is open for questions and answers. So do you have any question?
Are there any questions?
Man, no question.
A very big thank you to Dr. Markand for giving such a profound and informative lecture on Earth observation data for assessing sustainable development. So, I will explain vegetation assessment. In that, API time series predictions and what is the use of Android solar calculator app. It was very helpful for us, sir. Thank you so much, sir, on behalf of Department of Geology of District College for giving us your valuable time and presenting such a wonderful session. Thank you.
Thank you.
Professor,
Oza, sir.
On behalf of Department of Geology today, I would like to thank you personally for taking your valuable time and guiding our dear students. Thank you so much, sir.
Thank you, sir.
Most welcome.